This is section 2.1, and we are ready to begin this particular section. We're going to begin with problem number 1, 2, and 3, which asks us to list the intercepts for the graph. And this is a very straightforward type of problem. We just need to follow the steps. First one, if we want to find the y-intercept, we let x equal 0. So we get y squared equals 0 plus 81, or y squared equals 81. But we couldn't care less about what y is, so we want to, or what y squared is, we want to know what is y. So we're going to take the square root of both sides, and the square root of 81 is plus or minus 9. To find the y-intercept, or pardon, to find the x-intercept, what we do is we let y equal 0, and we get 0 equals x plus 81. We can subtract 81 from both sides so that x equals negative 81. And therefore the intercepts would be negative 81, 0. And that's gotten from here. And then these two would be 0, 9, and 0, negative 9. And there are the three intercepts. For example, number 2, we have 16x squared plus y squared equals 16. And so once again, I'm going to let x equal 0, and so we get 16 times 0 squared plus y squared equals 16, or y squared equals 16, and once again, we want to know what is y, so y would equal plus or minus 4. The other way to do this, or the other intercept, would be if we let y equal 0. So we get 16x squared plus 0 squared equals 16. That leads to this. Divide both sides by 16, and x would equal plus or minus 1. And so the intercepts would then be 1, 0, negative 1, 0, or 0, 4, and 0, negative 4. For example, number 3, we get y equals x squared plus 16. Once again, let x equal 0 to find the y-intercepts. And we get y equals 16. Letting y equal 0, we get x squared equals negative 16. And regardless of how hard we try, we never get real numbers, so there's no intercepts here. So the only intercept for this particular problem would be 0, 16. Now example number 4 does require a graph, and the graph is shown there. And what we need to do is we need to list the intercepts and then tell whether the graph is symmetric with respect to the x-axis, the y-axis, the origin, or none of these. And if we look carefully at that graph, there's only one place that it crosses the axis, and that is at the point 0, 4. Likewise, when we look for the x-axis, could we fold it at the x-axis and have the graph lay on top of itself? No. The y-axis is the same thing. Origin's a little bit different. We need to actually look at from one point to the other that goes through the origin, but this does not have origin symmetry either, and so there would be none of the above for this particular problem. Next group of problems, we need to determine whether the graph is symmetric with the x-axis, the y-axis, and or the origin. And this is a process that, if you follow, everything will fall out. So we get x squared plus y minus 81 equals 0 is number 5. So to tell whether or not we have x-axis symmetry, what we do, or the first thing we do, is to change all of the y's to negative y's. And so we get x squared plus a negative y minus 81 equals 0. And so this would be x squared minus y minus 81 equals 0. Then we ask ourselves, is this the same as the original? Well, no, there's a sign difference here. So that means there's no x-axis symmetry. To determine whether or not we have y-axis symmetry, what we need to do is we need to substitute negative x for x. So this becomes negative x squared plus y minus 81 equals 0. But negative x, the whole thing squared, is the same thing as x squared. So we get x squared plus y minus 81 equals 0, which means there is y-axis symmetry. Now, how we tell about origin symmetry is we let both the x's and the y's be negated and see if we come up with the same answer. So it'll be negative x squared plus negative y minus 81 equals 0. This is equal to x squared minus y minus 81 equals 0. And you see there is that sign difference. So there is no origin symmetry. And that's how we do all of these problems here. Example 6, same type of problem. What type of symmetry is there? Y equals x squared plus 5x plus 6. To test x-axis, we let y be negated. Now in this particular case, it's easier just to solve for y and compare that. So I'm going to divide everything through by negative 1. And the question becomes, is this identical to the original? The answer is no, so that means there's no x-axis symmetry. For the y-axis symmetry, we let y equal negative y. Oh, I'm sorry, we let x equal negative x. So it'll be negative x squared minus 5 times negative x minus 6. Or y equals x squared plus 5x minus 6. Very close to the original, but we have... Whoops, that should be a plus. That should be a plus. And that should be a plus. So that means, finally, after all these corrections, this should be a minus. And we notice that this is very close to it, but not exactly. So there is no y-axis symmetry. Finally, for origin, we let all variables be negated. And we get negative y equals x squared minus 5x plus 6, and divide everything through by negative 1. And we see once again it's very close, but no cigar. And so, as it turns out, there are none of the above. Now, number 7, there are many different ways to do it, but in this particular example, I find it easier to go ahead and do the multiplication. We have y equals the quantity x minus 3 times the quantity x plus 3, which of course equals x squared minus 9. And now, do everything we need to do. First thing we're going to do is to let or negate y. And divide through by negative 1, and we get this. Nope, they are not the same, so there's no x-axis symmetry. Now we're going to let negate x. Oops, that's a minus, not a plus. And this is identical to the original, so there is y-axis symmetry. And then finally, negating both of them, y would equal this, and therefore there's no origin symmetry. And the final example in this particular group of problems is to graph by plotting points. Example number 8. And we are asked to do y equals the square root of x. Now, with practice, you will learn which values you want to put in. Oftentimes, we like -1, 0, 1 for x, but the problem is -1 has no meaning in this particular case. So I'm actually going to start out with 0 because I know x, the square root of x, or the square root of 0 is 0. Then I'm going to do 1, and the square root of 1 is 1. But I'm not going to do 2 or 3 because those aren't numbers that work out very nicely. So then I'm going to choose number 4. Square root of 4 is 2. And then the next logical number for x would be 9 because the square root of 9 is 3. And so I have 4 points here, 0, 0, 1, 1, 4, 2, and 9, 3. And so all I have to do is to graph those points, 0, 0, 1, 1, 4, 2, and 9, 3, and realize this is not a straight line, it's a nice curved line as such, and that is the curve of y equals the square root of x.